back to the another tutorial, and in this tutorial we will deep dive with composable functions. Okay, so let me summarize what we are gonna learn in this tutorial is we're gonna learn how we can describe our UI in using in Jetpack Compose using Kotlin as functions, okay, in Jetpack Compose. So this is the first thing that we will learn. So we will no longer be working with XML files. So the good thing is there is no XML file. Everything the UI is actually generated by Kotlin functions, okay, in Jetpack Compose. So this is the thing, fundamental thing that we'll learn in this course. And then we will also learn some other advanced concepts like behavior properties of composables. I will be listing them each and every behavior properties of composables in this along with this tutorial. Okay, so without wasting any time, let's go through this tutorial. Okay, so as you can see here, this is a simple example of a composable function. Okay, and to create a UI in a Compose, it's very simple. You just need to annotate a function, any simple function, just annotate with a composable this annotation. Okay, so this annotation will actually tell the Compose compiler that this function is intended to convert the data into a UI. Okay, actually this is this composable annotation will tell the Compose compiler to convert this function the data to UI. Okay, whatever data is passed is converted to the UI. Okay, so this is a very simple concept. So you don't need to no longer work with the XML file. It's very simple, right? Simple, fast, and it's clean, right? And you can also easily preview your composable UI in using this annotation, preview annotation, and showing the background. You can also add other parameters here, as you can see here. Okay, you can just work along with it. Okay, so the function that you create in this way is called composable function. So this function, okay, this product card that is created in this way is called composable function, or you can also in short call this composables. Okay, so this function is called composables. And so this is the building block of your Compose. It's a building block. It's very important. It's a fundamental concept, guys. Okay, so the cool thing about composables is you can reuse the composable elements. Okay, so I'm using this product card composable function, composables, in this another composable function, that is product screen list, and I'm reusing it. Okay, so this is the cool part of composables. Is like you can reuse the UI, okay, wherever it is necessary. So I'm just reusing it. I'm creating this simple block of UI and I'm reusing it in the product screen list, as you can see here. Okay, so this product screen list will consist of product card. Okay, and this is the cool thing about composables. And guys, so there is another interesting concept that you have to understand, is like composables, they never they do not return anything. As you can see here, this composable function is not returning anything, right? So this is the important thing, that concept that you have to understand. And but what it's doing is it's not returning, this function is not returning anything, but it is emitting the UI. Okay, so this is the important concept that you have to understand. So composables are also immutable, so you can't hold the reference to them. You need to pass the data as parameter when you call them. So as a function is created in Kotlin, you can use all the powers of Kotlin. For example, as you can see here, I'm using a if and else conditional loop here. So if the product list is empty, then I need to show empty like a text saying that there is no product list to choose from, right? If the product list is not empty, only in this scenario I will just populate the UI with the product card, a list of product card, as you can see here. Okay, so I can also handle this kind of scenarios. You don't need to in your previous version of view version, we used to use view.visible, visibility is gone, or invisible. All these kind of scenarios were used in the view concept, but in Compose it's all pretty simple and nice and clean, as you can see here, right? I just use a simple conditional if and else. Okay, so this is also cool about compose, and these composables are actually very fast and without side effects. Okay, so this is the thing you have to understand. And now let's understand about recomposition. What is a recomposition? Okay, so the actually, as you can see, this compose my composables use parameters, right? Like for example, my parameters is like a product list. So these parameters provided to these composable functions controls the UI that is getting generated, that is generated by this composable. Okay, so this is also we can define this, redefine this as a transformation of state into UI. Okay, so the UI generated is always dependent on the parameter that is being passed. Okay, there is no way out. Like I mean, like the UI generated is all dependent on these parameters being passed. Okay, so this is the most important concept that you have to understand. The composable function is recomposed whenever new parameters are being inputted. Okay, so this phenomena is called recomposition. Okay, so recomposition happens in two scenarios. One is like when you reinvoke with a new parameters. Okay, or there is also another scenarios where the recomposition will happen is like when there is an internal state of function changes. Okay, how does the internal function state of a function changes triggers the recomposition? Okay, let's understand this. Okay, so in the product card, as you can see here, your card, this is the card. So whenever you click this card, like you know, there is a radio button, you have to select this card, right, this product card. But it will not happen automatically because your radio button should handle that scenarios, right? And this is all handled by this on click scenarios, right? So you have to add the related logic, and also whenever you select this right now it's handled using its product selected, like is being passed by default as a false, but this should be should be passed according to like the radio button is selected or not selected on the basis of your click, right? And this is the situation, guys. Okay, so we need to add the logic which will be responsible to recompose the UI whenever the user clicks to it. Okay, so this is the scenario when the internal state function triggers the recomposition. So this is the scenario when there is a internal state of your UI of a function, the composable functions that triggers the recomposition. So whenever user clicks it, the UI will be recomposed. Okay, so this is also another scenario where the recomposition will happen. Okay, so how do we recompose the UI whenever user interacts with it? We can just do it by passing the variables. As you can see here, I'm just passing this variable that holds the selected product. And so we use this Kotlin, like obviously we are using different scenarios here, step by step. For example, at first you just pass you will just pass like there is a no answer will be selected initially. Okay, obviously it's just selected to null, right? That's why UI will survive the, like this is the initial state. Okay, whenever there is a no answer is selected initially, so it's assigned to null. So we need to tell the composable that we when the variable will changes, recomposition should be done. To do that, we need to use a mutable state object. Okay, so this is the thing. And what is a mutable state? A mutable state is a observable type that is integrated within the compose runtime. Okay, so any changes to the state will automatically schedule a recomposition for any composable function that listens to it. So whenever the value of a this selected product will change, compose will recompose the UI, right? So its selected will be passed to, its product selected will be passed on the basis of the selected product, right? And if it is equals to the product, then the product will be selected, right? So Now let's note that creating a state object, it also requires that it should be called within the called remember. This remember savable, I am using it, but you can also call within a remember, because this remember will guarantees that the value is remembered and not reset when the composable recomposes. But why we are using remember savable instead of remember is because remember will not survive the configuration changes. To remember value across the config changes, we use remember savable. Okay, so this will also survive the configuration changes. All right, guys, you can just go to the necessary documentation here, and okay, so this is how the situation is being done, and we are also using the syntax like Kotlin's delicate property, like by this keyword. So doing so, this will change the type of our variable to an optional answer. Okay, so this syntax will let us work directly with the value of our underlining state. Okay, so this is our underlining state, so you just need to pass this selected product. Okay, and that's it. Okay, so now let's move further with our state and UI. Okay, so events changes the state. Okay, so events are the mechanisms for how state is updated in Compose. Okay, so whenever you unselected, like you have unselected this function. Okay, here this event called onSelected is invoked when the user interacts by typing the product card. Okay, so this will be called, and Compose runtime will automatically keep tracks of where like state changes occurs and recompose composables that depends on that state according to the accordingly. Okay, so the advantage of it is you don't need to explicitly observe the state or manually update the UI. Okay, so this is how the thing is happening here. Selected product. Okay, you pass the product, and then situation will be happening here. Selected product will be assigned here, as you can see here. Okay, so now understanding these scenarios, let's understand about now some behavior properties of composables. Okay, so you need to make sure that your composables are side effect free. Okay, and the behaves the same when the it is called multiple times with the same argument. Okay, so the first behavior property of composable is like composable functions can execute in any order. Okay, so like you can execute in any order, so it's not like my top screen will be executed first and my middle and like bottom screen will be executed on the like in this order. Like it can be executed in any order. Okay, so this is the first behavioral property that you have to understand. And the second behavioral property is like composable functions can run in parallel. Okay, so Compose takes advantage of multiple cores, which improves the rendering performance. Okay, so like for example, you can see the code runs with side effect. It's like with side effect free and transforms the input list to UI. Okay, so this code is pretty much side effect free, and this is the code that runs with side effect, and this affects the behavior of recomposition. Why this is what can you see the difference between side effect composable free composables and with composables with side effect is like, you see I'm adding some additional variable here, which is gonna like trigger some side effect behavior to our compose recomposition. Okay, so this is like you have to avoid this kind of side effect in your composables. Okay, so composable recomposition can be skipped. So there is also another composable compose behavior is like recomposition can be skipped as much as possible. Okay, so like you can see this example that recomposition skipping these composables. Like for example, during my recomposition, my top screen is not depending in any values, right? Only my middle screen is recomposition will occur only here. So the recomposition in my top screen and my bottom screen will be skipped, okay, because it's not dependent on any values, right? Input parameters, and only my middle screen has is dependent on the input parameters. That's why recomposition. This is the third behavior of compose, that is recomposition can be skipped as much as possible. And the fourth behavior is like recomposition is optimistic. So this means that the compose expects the recomposition to be finished before the parameter change again. So okay, if the parameter changes before the recomposition finishes, recompose will cancel the recomposition of the older parameter and restart with the new parameter. Okay, so now the final behavior of a compose is like compose functions will run frequently. Okay, so if your compose functions contain animations, obviously that animation will need to be executed for every frame. Then in this scenario, composable function needs to run frequently and fast to avoid the dropping of frames. So this is the 5 behavior of properties of composables. Okay, so now with this I would like to wrap up my tutorial, and I would like to summarize what we have covered in this tutorial. Is like we created a composable functions using the @composable annotation. Okay, so it is easy to create composables. As you can see that it's pretty simple, you don't need to use any XML, and they are pretty much reusable. Composables also should accept parameters. Obviously they always depend on their parameters to configure their behavior. So we use mutable state, remember savable, all this property to store a component state and have composable automatically track and recompose changes. And composables you create should be always side effect free. And some of the behavior of composables are they run frequently in an order and in parallel and can be skipped. And thank you guys for following this tutorial. Hope you like it. Please do subscribe me, comment if you have any questions, and catch you up in the next lecture. Thank you guys.